Good evening, dear participant. Good evening, all of you. Welcome to day 5 of our ongoing biostatistics workshop. Today, we are diving into the essential of regression analysis, one of the most powerful tool in statistical modeling. Together, we will explore the basics of regression and get hands-on experience using R to bring this concept to life. Let's continue our journey towards mastering biostatistics. Before inviting today's our resource person, Dr. Prayas Sharma, who will be a resource person during this session, I would like to have a brief introduction. Dr. Prayas Sharma is currently working as assistant professor in the Department of Statistics, Babasaheb Bhimrao Ambedkar University, Lucknow. Dr. Sharma holds a bachelor's degree in computer science and statistics, master and doctorate degree in statistics from Banaras Hindu University, Varanasi, India. He has qualified national eligibility test and obtained the junior and senior research fellowship from UGC, India. Dr. Sharma is a certified virtual teacher by the University of California, Irvine. Dr. Sharma has good knowledge of statistics, artificial intelligence and machine learning, business analytics and research methodology, along with the strong computational and programming skills. He has more than 10 years of academic experience, both in domain of teaching and research. He has worked earlier with the reputed universities like Indian Institute of Management, Sirmur, Gati Shakti University, Vadodara, and University of Petroleum and Energy Studies, Dehradun. His research interest includes survey sampling, estimation procedure using auxiliary information and measurement error, predictive modeling, business analytics, and operational research. Dr. Sharma has published more than 45 research papers in reputed national and international journals, along with one book and 2 chapters in book internationally published. He has more than 580 citations with H index 17 and I index of 20. So once again, I would like to welcome Dr. Prayas Sharma in this session. Now over to you, Dr. Sharma. I need just 1 minute. I make you co-host. Yes.
Yeah, thank you. Thank you, Dr. Chand. Hope I am audible.
Yes, sir, you are audible.
Great, great. Thank you for such a nice introductions of mine. And, I also recall a few things when you speak about me. Thank you. Thanks a lot. So, with your permission, yeah, shall we start now?
Yes, we should start now.
Right, good.
Yeah.
So, yeah, good evening, everyone. Today we'll be discussing about, as Dr. Chand said, we'll be discussing about the regression analysis, how it is important, along with their assumptions and practical importance, and that all we'll be doing through R. Uh, in the last session, we could not, reach to that because of the lack of time. But today, we had words already, and then we have prepared the session in such a way that we will definitely go into our studio and we'll do some hands-on, because that's definitely give you some practice dealing with the data along with the the conceptual understanding. And as we discussed in the last session, that definitely the conceptual understanding is very, very important. So I'll be just taking you through the some part of the conceptual understanding in case of understanding the relationships between the variables, and how do we assess those relationships, along with the along with how to measure the relationships as well, and how can we predict using those relationships means if there are two variables initially, then how can we understand the relationship between two variable, and can we use one variable to understand the nature and characteristics of the another variable. That's how we will be discussing throughout this session using the practical approach as well, right? So before proceed further, I'll just tell you first we'll be discussing about few things as the correlation, how to measure the correlation, what is correlation, and how to measure the degree and directions of the relationship between the two variables, and then further I'll take you through the regression, and then we'll be doing some hands-on, right? uh, Please feel free whenever you have any doubt. If you have, if you need certain clarifications, if you'd like to add something what we are discussing currently, please feel free, right? It's always better to make it interactive sessions than rather than listening to the one part from the another, right? So in our day to day life and into the field of statistics, we are always interested to know that whether the things which we are dealing is univariate or bivariate, right? And most of the time the study, specifically the practical study involves, it's always uses the bivariate data. At least means there are two variables involved, more than one variables involved in that. And then we are interested to know what is the nature of these two variables, right? Are they quantitative in nature? Are they categorical in nature? Are they qualitative in nature, right? And does they have any kind of relationship or not, right? Can we use one variable to predict the some kind of measurements of the another variables, right? So these all questions we have in our mind, and those questions will be resolved after going through these sessions, right? Let us see an example, and we'll be following these examples throughout our discussions. So here are two quantitative variables for each of the 16 students. Let us suppose this is the data given of the 16 students, and number of beer they consumed and the blood alcohol level. So how many beers they drank, right? One thing is given, and their blood alcohol level is given, which will be called in BAC. So we are interested in the relationship between these two variables, right? Are they related? First question. If yes, then what is the nature of the relationship? That is second question. If they are related and there is some nature, then what is the intensity of the relationship? How strongly are they related, right? So these are the questions which we'll be looking forward while dealing with the concepts of the correlation, and then we will certainly then see the mathematical relationship between these two variables. So we will talk about the regressions. Whenever we have any kind of data on the variables, it's very essential to know about the data, to explore the data, right? Because once you will explore the data, then you will know certain things about the nature of the data. And then once you know about these things, you will be always able to interpret the data into the better way. So to understand the data, to understand their relationship, you know first of all, let us start with a graph, right? And when we have the two variables, let us plot a scatter graph, right? Which can tell you the relationship between the two variables. How does it behave, how does it look like, and then what what kind of strong relation, weak relation they are sharing. Look at the overall pattern and deviation from the pattern if you have any, right? And then you can also use the numerical descriptions of the data to understand, to measure the overall patterns of the data. In this case, if we draw this scatter plot here, right, you can see that this is a plot against these 16 students where one variable number of beers is located on x-axis and the BAC is located on y-axis, right? And on any certain point, if you choose any certain point, as you could see on the slide, it shows the particular relation. Then if there are three number of beers, then the alcohol level corresponding will be 0.07 mg per ml bloods, right? So that is how we predict the scatter plot. And if you see this scatter plot, you could easily understand, right, that roughly this relationship is moving upwards direction. Is that clear? Right? So now, while seeing this scatter plot, you could understand that the relationship between the number of beers and the BAC is some kinds of moving in the upward directions, definitely the positive one, right? And then in your mind, you can have an idea that the relationship between these two are the positive relationship, right? So that means if one increases, another one is also increases. So while seeing this scatter plot, you can have this much of idea that these two variables are sharing the relationship. In this, one will be called as a response variables, right, which measures an outcome of a study, an explanatory variable which explain the changes in the response variables, right? So usually we also call it as the dependent variable and the independent variable. And our interest definitely lies in the dependent variables, how dependent variables varies with the change in the independent variables. Usually we call the dependent variables as y and independent variables will be as x, right? That's a usual nomenclature. Now, if you see this plot, right, this plot was given by an example which we have considered in the beginning, right? That's a number of beers and the BAC. There's another examples where the calories are given on x-axis and the sodium level is given on the y-axis. If you see the graph, right, if you see this scatter plot, do you think that calorie explain the sodium amounts? You can respond your answers on the chat box. Yeah, do calories explain sodium amounts here? The another graph you may see, there's a percent returns on treasury bills on x-axis and percent returns on the common stocks on y-axis, and then again we have plotted the scatter plot. Again, I'll ask you the question: the percent returns on treasury bills explain the percent returns on common stocks while seeing this scatter plot? What do you think? Any response? No? Left graph, maybe right, no. Okay. Okay. Thank you, Elena. Now, after plotting these two variables,
Sir, please unmute your mic. Dear participant, during the session, whenever you have any question or discussion, you can unmute your mic. You are allowed now. You are permitted. Thank you, sir.
okay,
Please carry on.
yeah. So after plotting these two variables on a scatter plot, we describe the relationship. How do we describe that question? So we describe the relationship by examining the form, direction, and strength of the association, and we look for overall pattern. So in this, you see the form is linear, curved, cluster, or no patterns. So this kind of forms you can examine. Directions, you can see either the positive, negative, or you may also see that there is no directions. Strength, when you have to measure the strength, you have to see that how closely the points are, how closely the points are from one another, right? So as close as you can find the points, you will find that there is very good a strength in the relationships, right? And another things you can see which is deviating from the pattern would be called as a outliers, right? So here you can see that this kind of, when the right hand side, is perhaps not explaining any kind of relationship between these two, right? Because it is all around, it's having no patterns, I believe. Well, here it's a kind of patterns if you draw would be living like a, would be looking like a positive patterns and upward patterns, as she said, right? Thank you. So when you see, you have this graphs, right? And if you have the linear relationship, definitely your scatter plot would be look like this. If you have the no relationship, your plots will be look like this. And if you have the non-linear relationship, which is sometimes not a linear, so you can be having the this kind of plots when you draw using any two variables, right? uh you understood that's a positive and the negative one, and this is the no relationship between the x and y, or the dependent and the independent variables. Now, when all the points are in the line, right, then the strength of the relationship between the two variable is very, very strong, right? And there is no much variations, right? But when the points are not in the line, though they are, they are closely, presented in the graph, then there is a relationship, but that cannot be the very strong relationship. Rather, that can be a weak relationship in the in the two variables, right? And how does it affect whether there is a strong relationship or whether there is a negative, weak relationship? How does it affect? We'll I'll let you know whenever we'll discuss about the regression process, right? So yeah, it's given here. So with a strong relationship, definitely whenever you are finding or whenever you are predicting the one variable using the another one, your prediction would be very, very high, very, very close to the actual value, very, very close to the estimated, uh, means close to the actual values, and the difference between the actual one and the estimated one would be very, very less. Definitely it's opposite in the when there is a weak relationship, so you might not be able to get the good estimate, or perhaps you should look you should look for some another variables which is having the good associationship with the variables, right? I'll just take into one another plot right here, where the state median households income given on the x-axis and the state per capita incomes given on the y-axis, and I just tried to know that whether there is any relationship between them or not, right? Definitely this shows some kind of relationship, right? And you can see that it's moving in the upwards. But as it moving in the upwards, you can also realize that it is being scattered now, right? So when it is starts from the beginning, you can see there is the strength, means the points are closely available to each other, or points are close to each other. But as soon as we are moving upwards, you can see the points are distracting, is being scattered. So in that sense, we can say that the relationship is not very strong, the relationship is a weak, in fact, right? On the other hand, we have the average number of heating degrees per day, and then the average number of gas consumed per day, and you can find that this relationship here. And while seeing only, you can understand that these are the points which can almost be on this on a line, right? And therefore they are sharing a very, very strong relationship between these two variables, right? Hope it's clear how to see this scatter plot and understand, right? Yeah. So now the scaling also can be have an example, right? If I'm trying to draw two plots using the different scales, right? Then also there would be some kinds of uh, some kinds of patterns would be changing. So if you can see this first graph, pulse rate versus the time spent on swimming, and here if you can see the pulse rate and the sign phenomenon using these two, perhaps will give you the different idea, right, while seeing the scatter plot. So using an inappropriate scale for the scalar plot can also mislead to you while getting the information about the relationship, right? So always use the appropriate scale for the scatter plot, and it will give you the right correct impressions about the relationship in general. Both variable could be both variables should be given a similar amount of space, right? Plot roughly squares, points should occupy all the plot space, no blank space should be there, right? Or as far as possible, please try to follow these things while preparing the scatter plot so that you can have the appropriate scatter plot, right? Any question? Good.
Sir, excuse me, one question. How to deal if you have, how to say, a little complicated scatter plot and we don't have an idea is any relation or not? Because I know that it's possible to use different functions like quadratic, logic, and so on. Is maybe any rule or idea how to do that? Thank you.
When you say the complex scatter plot, then I don't exactly understand what kind of complex, complex scatter plot. So if it doesn't have any kind of relationship between, means if it doesn't shows any kind of pattern, right, any kind of trend, then definitely there would be a no relationship. No relationship, but I won't say there's zero, but definitely it won't be the any kind of relationship which can be used to predict the one variable based on the another variable. So maybe that will be senseless for our prediction purpose. Yeah. Okay.
Thank
So
you.
yeah, rest is next is the outlier. So usually we see that the means the general perception is the things which is perhaps very very far away from our data. From our data, it's the outlier. It's but the problem is, you see the two plots here, right? One, you can find there is the data till maybe 6 and 6, right? We have only plotted, and then after that we have a data on uh, perhaps 9 and 9, right? 9 comma 9, so it is presented there, and that is far from there. But this is not an outlier. This is not an outlier, right? So outlier is usually, at a very basic level, is the value that has very low probability of the occurrence. But this, if you find it here in this scatter plot of the first one, it's very high probability of occurrence because it's on the same line. So if I extend that line, it gives you the, you know same behavior as we could see on 2, 2, 3, 3, 4, 4, and so on and so forth, right? Though we could not have to have a data and we have this blank space, and because of that, there's a gap, right? But that is not an outlier. Whereas in the another one, you see there is a positive relationship going on the line, and one point is far away from that line, which doesn't have any kind of relationship with this line. So that will be called as a outlier, right? So outliers are basically the points that falls outside of the overall patterns of the relationship. It doesn't mean that it's only the far from the relationship. Okay. Yeah. Again, there are two examples. So you can see in the first one, it is not an outlier, but in the second one, it is an outlier. So while presenting this data into the scatter plot, you also will you will also get to know that whether there is an outlier into your data presents or not. Yeah. Good. So this is another scatter plot of IQ square and the grand proud average, right? which describes the words that this plot shows, describe the direction, shape, and strength, eh, right? And are there outliers? What is the deal with these people? Means what is the deal with these two peoples which is behaving like a outliers, right? So you can have this any kind of data, you can plot it all, and the data which is far from the far from any kind of pattern would be called as the outliers, right? uh yeah, so we have the different categorical, we may have the different categorical variable in fact, right? And this can be presented, and then after that we can have this line which can be a best fit to this line. So I'll just quickly take you through all these things because I hope you must have understood. Again, there is a plot, scatter plot, and then there is a relationship which can be predicted over here, right? And you could able to understand. Now, when we have the categorical explanatory variables, right? So you cannot make the scatter plot, but you cannot compare the different categories side by side on the same graph, maybe using the box plot or something, right? So you can see here, you can see this box plot, right? And you can compare their behaviors, you know, how does it vary. So comparison of incomes for different educations level for 5 categories. So not HS grad, there's some colleges, bachelors and advanced. So you can see their incomes as well, right? So their incomes is, more than the another one if I compare the advanced one. And that is also the higher side is higher and lower side is low. And you can also see there's highest point is quite high as compared to the another one. Okay. So here, okay, fine. Uh, right. If I show you this graph, right, what associationship, what kind of relationship do you think here? Yeah, any answer? Now, any answer? When both the variables are quantitative, the order of the data points is defined, right, entirely by their value. But this cannot be true in the categorical kind of data, right? And therefore, we are, seeing this line and seeing the relationship between them. When an association is more,
Sir, excuse me, sir, your mic is not stable.
hello, it's fine now?
Yes, sir, it's fine now.
Okay, okay, just a minute. Yeah, so when an association is more complex than the linear, as someone of you might be telling, we can still describe the patterns not by the linear or curvilinear, but by the smoothing the scatter plot. So you can see here there's a time and accelerations, and this kind of graph is written. So if you would like to fit this data, right, definitely a smoothing curve will be required. But then now to predict or to understand this kind of relationship is quite difficult, right? So when a data set does not have many on y values for a given s, the software smooths from an overall pattern by looking at the y values for point the neighborhood of each x values, and the smoothers are residents to the outliers, right? And then overall patterns was calculated by a software scatter plot smoother rather than any of this regression point or regression line. Yeah. So as I was telling you in the beginning, once we are interested in the directions, then we are interested in the intensity of the relationship. And to measure the intensity of the relationship, we have the correlation coefficient denoted as R, right, which can be calculated using the formula available on your slide, where we have two xi's and y's points of the data, and then we can predict using these formulae, and this will tell you the strength and shift, right? So it may come, it may varies from -1 to 1, and then as it's closest to 1, it shows the higher strengthship, higher the strengthenship in the data. If it is, approaches to 1, it shows that there is a positive relationship and very, very high relationship between the two variable. If it approaches to the -1, then it shows that there is a negative relationship, and that is also very, very higher negative. So if it remains towards or around 0, then we can say that there is no much relationship between the variables, right? This R, the correlation coefficient, is independent of the units, right? That means we can compare the two correlation coefficients altogether. We need not to check about their units, right? And we rid of these all units when we standardize to get the z scores, and therefore there is no units, so you can also compare. That is the one of the advantages with the correlation coefficient, right? So as we were discussing, it varies from -1 to 1, and you can see here their interpretations for the different values of R, right? So R is correlation coefficient, which tells you about the quantitative measure of the strength, intensity of the relationship, as well as the direction of the relationship, right, between two quantitative variables. One important thing here is to be mentioned, that this correlation coefficient given by Carl Pearson is only measure the linear relationship between two variables, right? So it assumes that whenever we are talking about or calculating the relationship, it's the linear one. So when you say that it's having the relationship very, very high or very, very low, actually you are talking about the linear relationship, right? Even when you say that there is no relationship, sometimes you calculate the value of R and you get the value as 0. So you say that there is no relationship. It's exactly, there is no linear relationship, right? It might have certain other kind of relationship. You might have the relationship of kind of y is equal to x square, but you cannot have the relationship of y is equal to 3 plus x, right? That's what it means. Okay, so if you see these two graphs, right, pulses and the time and their means, right, we have seen R is equal to -0.75. It shows some patterns downwards, right? So therefore it's negative. Whereas in this here, if you show the another data, which is R is equal to -0.091, you could easily understand that this is less variable as compared to this, right? Yeah, so we were discussing this correlation only describes the linear relationship, nothing else. Yeah, these are the some influential points which are correlations are calculated using the mean and standard deviation, and those are not resistant to the outlier. So these are the some points which is treated as the outliers. Here is the outliers actually, but this can be taken into the consideration, while this could not be taken into the considerations, right? And obviously, here if we compare this, majority of the points remains same, right? But one point you see is varying from the all these another set. So if you consider this point into your into calculating or understanding the relationship, definitely it will deviate, right? Deviate your strength of the relationship. As you could see that it comes from minus 0.912 to 0.075. So in that case, you can treat this as an outlier and better to remain it out from your data set, right? Okay, right. So what is explanatory variables? So the variables which describes the form, direction, and strength of the relationship, and we can use this while estimating the R, right? So if women always marry men 2 years older than themselves, what is the correlations of the ages between the husband and wife? So we can have this relationship, and this is a straight line. So as I have given you the example that it always measure the um, linear relationship of a kind y is equal to x plus a, right? And it it cannot measure the relationship or the type of y is equal to x square, right? Or any other kind of relationship which is not a linear one, right? Okay. So we'll quickly move now to the simple linear regressions. And simple linear regressions means it's a linear, that the relationship whatever we will be discussing here would be a linear, and simple means it's having only one exploratory variables, right? To get the idea about the our response variables, or one independent variables to have an idea about the dependent variables, right? Usually, our interest is to know or forecast the value of the dependent variables from using the different values of the independent variables, maybe x1, x2, and xk's, right? And we would try to analyze the specific relationship between the independent variables and the dependent variables. Keeping it simple here, that means we are only using one independent variables to predict the dependent variables, right? If we talk about the regression line, then regression line is a straight line that describes the mathematical relationship between a response variables and the explanatory variables. That means how the response variables behaves if we change in the explanatory variables. And definitely it can be used further to predict the value of the dependent variables for the given values of the independent variables. Just for a simple examples, if you talk about the building a house cost, right? And yeah, building a house cost and about the size. So this is a deterministic relationship, that house cost is equal to something plus 75 into size. So as we define the size, right, we can get the values of the house cost. And the same is being given here with respect to this line. So you can see that as house sizes increases, the house cost is also increases. That is the meaning of this line as well as this scatter plot, right? Now, obviously, it's not always possible that the house of the cost would be varying on the size of the cost, right? There are certain other things which will be influenced to the house cost, right? And those all things let us consider as the random one, and then we have included it as the epsilon, right? Fine. So this is the simple linear regression model where there is one variable y, there is one variable x, right? And then we can write it as beta 0 plus beta 1x plus epsilon. This is a probabilistic model. Earlier, if whatever it was only the house cost plus is equal to some beta 0 plus beta 1 into x as a size, this was the deterministic model. For any value of this size, you will get the households, right? There is no randomness involved. But here, there is a randomness involved, which may be called as an error variables or error component in the model, right? Y, x, beta 0 and beta 1, you already know. Yeah, so beta 0 is a y intercept, and beta 1 is the slope of this line, right? Which also uh, which is also useful to predict the value of the y. Beta 0 and beta 1 are the unknown population parameters. Therefore, we have to estimate these values from the data, right? And once these value would be estimated by the data, we can write it as y hat is equal to beta hat plus beta 1 hat x plus value of some epsilon if there is. So the estimates are determined by drawing a sample from the population of the interest, calculate the sample statistics, and then producing a straight line that's cut into the data, right? Now there can be many several lines. If we try to draw the lines, right, and my interest is that line should be passes through almost each point, or if not then majority of the points, that is my interest. So if I can plot these three lines, which line is the best line, right? Which line is the ideal line? Because if you could see this line, you will see that almost all the lines into the consideration we have in both of the images are passes through almost the similar number of points or the same number of points, right? So which line is the best one? Then the answer is which minimizes the sum of square difference between the points and the lines, right? So we have plotted this here, right? Plotted this here, and then we have this line, right? If we compare the lines with this point, this is a line, you can see it is not going through any of the point, right? But we have 2 points here and 2 points here. So if we see, if we treat that this is the best line, that this is a difference from the line of these points. And then if we calculate the sum of the square of the differences, right, this will be here and this will be here. So this is 6.89. Okay. Let us see the another line, which is the horizontal one. If we draw, right, and then again calculate the values, that is 3.99. It means the second line which we have drawn, it's having the better understanding about this phenomenon which we have drawn using those 4 points as compared to the line which we have drawn earlier. Why? Because the smaller sum of square is presented in the second line as compared to the first line. Clear? This is called the method of least square of getting the best fit. Okay. So now to calculate the estimates of the line of the coefficient that minimizes the differences between the data points, you can calculate like this, beta 1 and beta 0, and then you can get the value of this regression equation or the estimated regression equation where B0 and B1 can be given. Definitely, as I said earlier, B0 and B1 would be given by the data, right? Let us see an example. A car dealer wants to find the relationship between the odometer reading and the selling price of the used car. It usually happens, right? You must have come across earlier with such kind of examples into your day-to-day life. So we'll see here. And a random sample of 100 cars is selected and the data recorded. You have to fit the regression line, right? Obviously, which one is the dependent variable here or which one is the variable of interest? Definitely the price of the car, right? Because price of the car would be helping you to buy the car or to decide this whether to buy a car or not. To get or plot this line, we required such values, certain values. So we have calculated using the data, right? And then we can prepare a model or regression line which could be useful to understand the price for a given value of the reading of the odometer, right? So X is the odometer reading, whereas Y hat is the estimated value of the price of the car. Clear? The same you can do using the Excel. You can go into the tools, data analysis, and then regression, and you can plot it here, right? And you will see this graph, right? And this graph shows that multiple R means the relationship between the two variables, R square, how well your independent variable is predicting the dependent variables, right? And so on, so forth. Here you can see the intercept values, and here you can see the value of the, this is the beta 0 and this is beta 1, right? So now while seeing the data, while calculating the data, the same we have done using these calculations, and same we can get using the software as Excel. So again, y hat is 17.067 minus 0.6236 x, right? Clear? Okay. Again, if we draw this, the whole data, we could see this kind of graph, this kind of a scatter graph, and if we can plot this line, we could see there is a negatively linear relationship, means it's going downwards, and that's quite true in practical aspects, that as the odometer increases, the price decreases, right? So beta 0 is this one and beta 1 is this one. Please don't interpret the intercept as, means if x is equal to 0, right, the price of the car that has not been driven, right? Right. Whereas 0.6.23 is the slope of the line, as I said, means beta b0 b1 in fact. So for each additional mile on an odometer, the price decreases by an average of 0.0623, right? So it means if you are having an odometer increases of 1 unit, right? It's given in the miles, we call it as 1 mile. So price will be decreases in the 1 unit, that is $1 here. Fine. That is the meaning of the 0.0623. And why we say decreases? Because there is a negative sign. So that is the meaning of the negative signs here, right? These are certain assumptions about the error terms which we use in the regression line. So it's a critical part of the regression model, that probability distributions of epsilon is normal. The mean of epsilon is 0. The standard deviation of epsilon is sigma for all values of x, and the set of errors associated with the different values of y are all independent. So error terms are independent, right? Uh, this is the meaning of this we have plotted. So let me just quickly go through it. Right. Now, how to assess the model? This is very, very important thing. The least square method will produce a regression line whether or not there is a linear relationship of x and y or not, right? Consequently, it is important to assess how well the linear model fits the data. Several methods are available to assess the model, and all are based on the sum of squares of the error, which we usually calculate here as SSE, right? Given on this on your slide, right? Standard errors of the estimator. So the mean equals to the 0. The sigma epsilon is small. The error tends to close to 0, close to the mean 0. Then the model fits the data well, right? Therefore, we can use sigma epsilon as a measure of the suitability of using a linear model. As an estimator of sigma square is given SC, and SC can be calculated using this formula. You can have these calculations, right, to understand whether your model fits well or not. So you can see here the SSC values, right, and you can calculate these SSC values to have an idea. Okay. Next is the coefficient of determination. So as I said while describing you the R square, and R square is this one minus SSC upon sum of square of this. So we can get these values. which also explains you the overall variability in the y, right? And how does it explain with the help of the x, means the independent variables. The overall variability can be explained into, can be segregated into two parts. One is the regression model, another one is the errors, right? And then we can have the total variability in the y as SSR plus SSE, right? And this is the formula for calculating the R square, which can give you an idea about how well your model is explaining the variations in the y with respect to the value of x, right? Closer the value to 1, your model explains the value well. Closer the values to 0, your model doesn't explains the value to the to the dependent variables, right? Let us see an example here. One of the most important applications in the market, finance market, right? And it is assumed that the rate of return of a stock is linearly related to the rate of returns of the overall market. So R is equal to beta 0 plus beta 1 Rm plus epsilon, right? You know the meaning of beta 0, beta 1 and epsilon. R and Rm is given here. So we run using the data and we could see this outcomes, right? We could see this outcomes. Now, if you see that TSE is what? TSE is what? Total stock returns, right? So this is a measure of the stock market related to risk, and in this samples of the 1% increases, the TSE returns the average increases in the total return as 0.8877 percentage. Or you can another see that for 1% in for 1 unit increase in the TSE return, there would be average returns in the total returns of 0.8877, right? This R square is 0.3137, right? What did I say before a slides? That better the value of the R square is closer to the 1, the model is better explaining the behavior or the variability in Y with respect to us. As it decreases or as it approaches to the 0, it's not giving you the good measure or good explanations of the dependent variable with respect to the independent variables, right? Here it shows that only 31.37% of the variation is being explained, right? So do you want your model to be explained only 31.37%? Perhaps no, right? So in that case, you have to look certain other variables which can influence to your dependent variables, right? So in that case, when you can find, you will be having a good idea about the predictions, right? Okay, that's all from the conceptual side of the linear regression model, right? If you have questions, you may please ask uh, to the conceptual side of the correlations and the linear regressions, right? We may discuss it before we proceed in the application parts or perhaps the hands-on part on the R. Yeah, no question. Fine. So if there is no question, we'll just move quickly uh, on this getting the regression part here, and we'll see how it can be done. Let me just share my slides. Yeah. Yeah. Thank you. Thank you. Raj. If there is any question,
Third, your mic is not stable.
Hello.
There is no voice.
Dear participant, please stay connected. I think there is a network issue. Professor will join very soon. Hello, sir.
I was disconnected.
Still, sir, your voice is very.
Is it fine now?
Yeah, it's fine now.
Okay. Okay. Thank
Are you able to share the screen?
Yeah, yeah, I'll do that. I'll do that.
Please do now.
Yeah, thank you. Okay, so this is a basic example where the test score is given, right? And the student teacher ratio is given, right? And the data is given. You can see, you can also plot the scatter plot using this data, right? And then further you can try to explain the relationship between them, right? And let us assume that we consider the relationship as test score is equal to 713 minus 3 into STR, right? You may ask that, sir, how have you decided this, right? The minus sign, or you can see the data and you will be able to well understand by yourself, right? Further, we can do this if we plot this here, right? You understand that it's it's having the plot as per the score given, but it is far from the value of these points, right? Which is perhaps the error, right? And therefore, rather than writing the model into this form, test score, or or y is equal to bx plus a, we should treat some of the other factors as well into our model, and then perhaps the test score will be beta 0 plus beta 1 into str plus other factors, right? And similarly, we can write into the general form for any values of yi, there is a beta 0 plus beta 1 xi's and plus ui's. So ui's are nothing but the random terms, random errors, which can have certain properties as we have discussed already, right? Now we need to, for for making this model, for in fact making this model ready with respect to the data, right? We can have to get the values of the beta 1 and beta 2, which is the population parameters, and generally it's a unknown one. So with the help of the data we need to calculate. So I'll take you through an example, through an examples of the data, which is given the score to the student teachers ratio measured in the Californian school, and the test score in the district wide average of the reading and the math score for fifth graders, right? Again, the class size is measured as per the number of students divided by the number of teacher, which is called the student teacher ratio, right? This data CAS or CA schools already available in the R under the package called AER, right? So let us just stop my screen here and share the R studio environment with you. Hope this is visible. Yeah, it's visible, I believe, right? So first of all, we will see the
Yes.
first of all we will enter the data which we have seen on the first slide, which was STR and test score for 7, for n is equal to 7, means 7 data points were there. So let us see that. You must be knowing that, if you are aware about the R softwares, that we can combine the data using this way. So I have written this, right? First of all, let me just clear the console. So Control L will be used to clear the console so that you can start from here, right? Let me just, yeah. So I'll just take it here for executing this commands. We can use the Control Enter. So Control Enter. So once I use the Control Enter, it means I have saved the data, this 15:7, or the state the data student teachers ratio, in the variable name called str. R is a case sensitive language, so please understand that if we have written capital or small, it will keep in mind while executing or while running it, right? So you can write these codes along with me perhaps, or if you want I can share the codes with you. You can run there and then perhaps we can discuss something common. The second one is the test score. Again, I have taken it executed. So value which you can see in the console, right? The str equal to str. Str is student teacher ratio. We have written in short is as str. Clear? No, S is not equal to S. Yes, that's what I was saying. It's a case sensitive. When you write capital S, it's capital S. When you write small s, it's small s, right? So you need to write using the same case what you have written earlier. So for example, if I write, if I would like to see here str, you see my console, right? Right? It won't find the str. What is str, right? But if I write here str, capital str, it knows what is capital str, so it will give me the values of the capital str, right? Hope it's clear. Fine. So you can see the str and you can see again the test score, what has been taken. We have both. Now let us see the plot. As I said in the beginning, to explore any kind of data, first try to see the scatter plot so that you can have an idea about the data, what it, how does it varies and how does it behave. So let us plot this. Yeah. Sorry, yeah. So this is the plot, right? Hope you can see this plot. The similar plot we have drawn. One side there is STR on x-axis and there is a test score. Clear? Can you tell me that which kind of relationship do you see using this scatter plot?
Sir, it seems no correlation. I mean, points
It
are widely
seems
scattered.
it
No
seems
correlation.
there is no correlation. Okay. Anybody else?
Negative correlation.
Negative correlation. Okay, good, good. Fine. Now, as we could see generally that we could find using the data, and we could see that for if we create here a regression model, so we had the value of beta 0 as 713 and value of the beta 1 as -3. So we can draw a line, right? And for this we can use the command AB line with the given coefficient. So let me just do it. Yeah. So there is a line which can be drawn, right? Though there is no good relationship between these two variables, right? And perhaps the test score and the STR is not very well related, right? We can also see the correlation between them. Let me just write here. Yeah. Yeah. So there is a, you can see here that there is a negative relationship. That's perfectly fine. But it's a 0.55, right? So the strength of the relationship is very weak. Clear? But still that can have the relationship between them. Why it happens? There are two, there might be two possibilities. One, that it's really behaving the negative relationships, right? Second, because of the lack of availability of the data. So we can have only 7 data points, and only 7 data points is quite less to understand the relationships on the two variables, right? Therefore, while only having these 7 data points, we cannot generalize this usually for STR and test score relationship. However, if we have to do this based on this data point, definitely your answer would be a weak negative relationship between these two variables. Is that clear? Okay. Now let us see an example and bigger data sets, and let us try to do all those things which we have done, or which we have discussed in the earlier slides. This was just an example to take you through how you can do it manually. If you have to manually enter the data into R and then perform certain kind of exercise, right? You will be getting more clarity when we'll find these uh, when we'll do this exercise which we are going to do now. Are you with me? Yeah. Better you can write, and if you can if you can keep on writing along with me and executing the codes, that will certainly gives you the more confidence and understandings of the topic. If not, then perhaps be with me, we will discuss, or you may certainly ask certain things whatever comes into mind, right? Okay. So as I said, we will be using a data of CA schools, and that data is available in the package of AER. So if you don't have that package, I have already installed that, so I need not to do that. If you don't have that package, you can run this command install packages and you can do that. Fine. If you want me to share the codes on the chat, I can do it for you. Otherwise, if you are comfortable, it's fine. Okay. So if I run this here, right? Just give me a minute. Let me just clear this. Yeah. So I just take the library, right? Once the library is there, I will load the data so that the data is available. Those who those don't know what is CA schools, you can just put a question mark and then CA schools there. You will get a descriptions of the data frame CA schools here. So the data set contains data on the test performance, school characteristics, student demographic background, school districts in California, right? And it comes in the data CA schools. Its nature is data frame containing 420 observations on 14 variables, right? What are those variables? District, school, country, grades, student, teachers, all works, lunch, computer, expenditure, income, English, read, math, and so on, right? These are the details. So whenever you are not aware about the data, it's always better to see the data here, get the informations about the data first, right? Next class, which kind of data is there, right? So you should know which kind of data is there. That's one is stored as the data frame, right? Now, if you would like to see what are the different heads of this CA school, so you can see here the district, school, country, grades, student, teachers, and so on, right? So it's available information about all the data points for 6 rows. So this presents, when you write head CA school, it presents the data up to 6 rows for each of the columns. I hope you are getting it right. Now let us calculate the CA school STR. And when I showed the slide, I told you how to calculate the STRs. That is students divided by teachers. So those students are available in the dataset CA schools, and student is one of the column. Similarly, teachers is one of the columns. So if I can divide these two, definitely these are the quantitative variables. So if we can divide these two and let it store as STR, that's what I am doing in the line 27. Clear? It's now save as an variable of CA school $str, means under the CA school we have taken it as STR, a new column. Similarly, we have to calculate the test score, right? So test score would be given in the line 29, and that's how we have calculated. At any point of time, if you would like to see it, right, you can just type it and you can see it, right? I'm not doing it here, but you can just type the name CA school underscore score. You will be able to see that.
Yeah, perhaps it's clear. Okay. Now, let us compute the sample average of STRs and the scores, test score. So, average STRs, definitely we know that in R, we can use the mean. Okay. So, it comes as mean CA school STR. The again average test score would again be calculated mean of CA school dollar scores. When we write dollar score, it means we are calling that particular variable under the data frame CA school. Is it fine? Are you with me? Yeah,
Yes, sir.
great. Now you have to calculate the standard deviation. So we can calculate the standard deviation as all. As you know that mean and standard deviation is already present here in this R environment. So we can directly use mean and SD rather than calculating it through formulae. We can definitely calculate it through formulae at any point of time. But since it's given directly, it's so better to calculate directly. That's the advantage of the R software. Yeah, any question? Please feel free if you are asking any questions, right? And if there is any doubt, you may also write in the chat box. I am continuously visiting the chat box so I can respond. Okay, so as the STR, we have done that. As the score, we have already done that, right? And we have taken the, quantiles of these values, quantiles of STR, quantiles of test scores as well, right? Now, let us combine these all things which we have calculated as a data frame, right? As a data frame, and that is comes in the distribution summary. And now if you would like to see the distribution summary, right, let us suppose I'll just put it here. So you can see that average, standard deviation, quantiles, quantile means all the three quartiles, right? And then for four variables. And what are those four variables now? Is the STR, test score, SDSTR, and this fourth one, right? Now we can plot this score and the STR here as we discussed earlier to know the information about the data is better to plot it first, right? So we can plot it here and you can see the plots, right? Is the plot available for you?
Yes, sir.
Good. What can you say about the relationship between the STR and test score here? Which kind of relationship do you feel?
None.
Yeah. Let us see the correlation between them.
It seems a very good correlation as far as I'm seeing the points are very much clustered together. So it looks like a good correlation.
Oh, yeah, sorry, can you come again?
Hello.
Yeah, please.
It seems like a good correlation as far as I see from the scatter diagram, since the points are very much close to each other.
Mhm,
That is, this is my observation. I mean,
mhm.
it looks like something like that.
Uh, Definitely, the points are closer to each other, right? But then they are not following any kind of direction. So if you could hear the my conversation, I say that first thing is to see the direction. Does it have any direction? If yes, then we will be interested to know what is the strength of the relation. Am I clear?
Yes, sir.
When you are not able to find any kind of direction, right, then it's not meaningful to see the strength of the relation, right? Because the
Okay.
ultimate aim of this all exercise is whether we can have the knowledge or the characteristics of the another variable using the one variable, right? And that all starts with the directions and then further the strengthening, right? Okay. Now we'll attach this data here. Okay, fine. Allow us to use the variables combined directly, and then let us calculate the beta 1, right? So we have calculated the beta 1 using the formula which we have seen. Then beta 0, we have already calculated the beta 0. And now let us write or let us make a linear model between the score and the STR, between the score and the STR, and that all with the data of the cache pool. So this is the you may say this is the command for doing so. So I've done this, right? This is the linear model. Now, if you would like to see the linear model, means if you would like to see the estimates and the intercept, then you can run again the linear model and you will see that here the intercept is 698.93 and the uh, slope is minus 2.28, right? Which, which tells us that there is a negative relationship, right? And we could also see with the help of this diagram and the correlation that there is a negative relationship between these two variables, and that is also not very strong, right? Now let us add the estimated regression line to the plot, right? And then we will change the ranges also from this plot to make it better understand. Yeah. So now you can see that we have taken the different ranges of the x-axis and the y-axis, right? Earlier it was from 620 to 700 and from 14 to 26, means STR was varies from 14 to 26 and test score were varying from 6 to 70. When we have done that, again the test score 600 to 720, but now the scores would be 10 to 30, right? So this just to get the better understanding. And then again we can draw a AB line using the intercept at the slope which we have calculated with the help of the linear model. So this is the line now. This is the line of the best fit in fact, right? This is the line of the best fit even in this scenario, right? Okay, that is being repeated, sorry. Now, if you would like to see the model summary, right, we can use here the model summary, and once we want to see it, we have to again write the model. So once now you can run the model summary, it will tell you about the formula which you have used. So that is LM with the help of the data. This is the residuals, quartiles, median, etc. These are the coefficients where the intercept and the slope is given. And again the p-values. So you can see this p-values is less than 0.00001. So that means it's significant even at 1% level of significance, right? And you can also see the multiple R square and then the multiple R square and then adjusted R square, right? F statistics and then p values as well. It shows that definitely your model is not the good model for estimating the. Okay, by the way, may I ask what are we estimating or what are we predicting here?
The test scores.
Right, good, very good. So it's the model is not very good for predicting the test scores with respect to the STR, right? And that we could have already understood while seeing the correlation. That was the advantages of the understanding the correlation or seeing the scatter plot, right? Now, if we calculate the R square here, right? And let us print it into the console. That is again 0.05, right? That has been here. So this is given by the software directly the R, and this we have calculated using the formula which we have seen on the slide. Clear? Now we can also compute this SER manually which was given, right? And we can print this here using certain values. You can see here the SER is given. Okay, not given here. So we can calculate this manually with the help of the sample. Is that clear? Any doubt? Yeah, anyone?
But sir, this will be for the characteristics we have taken. When we change the characteristics, it might be possible that we may get some relationship. Is it so?
Good, very good. So I could understand you are saying that if when we are calculating the test score based on the student teacher ratio, it might be better if we can compute this based on some other variables, right?
Yes, sir. Yes, sir.
Yeah, definitely we can do that. So good. I'll just ask you to do it. So can we calculate the score based on the expenditure? Yeah, you have the data now. Can we calculate the test score using the expenditure? Just tell me. And if yes, then whether it's better model to this which we have predicted or not.
Sir, I don't think so, because expenditure is means not related to test score. That is my understanding.
Okay.
Means what will be the criteria for selecting these characteristics from data frame? Means it logically seems that test means this ratio might be dependent. This ratio might decide this test score. So, is there any parameter to
Okay.
decide the
Do you?
characteristics for data frame?
It's
Yes.
Yeah. It's actually depends on whether certain variables or certain things are related or not. Why I did say the expenditure? It's the school expenditure, right? So don't you think that the school expenditure can have a positive impact on the test score?
Yes, 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 sir. Now,
Th-
if it is a school expenditure,
Yeah, that's what I said. It's the school
yes,
expenditure, I believe,
yes,
right?
sir. Certainly, certainly, sir. Yes, sir.
So that's what I said. Just try to see whether there is a reasonable correlations between them, and then further can it be used to predict the test score, and does it better model than this what we have prepared based on the STR or not?
Yes, sir. Yes, sir.
Yeah, I can share this. Uh, I can share this. Wait, these codes with you, and then you can change it into these codes directly, and you can directly get the values, right? So this file is available on the chat box. Hope you have already installed the R software. Yeah.
Sir, for every parameter, then we have to check it,
No,
or
obviously, see,
randomly we can decide these parameters.
no, obviously, as initially you said that the expenditure is not at all related, and then when I asked, you understood, and then you say yes, it might be affected. So we need to understand that if our dependent variable is the test score, what are the other variable which can influence to the test score, right?
Okay, sir.
So you
We
have
should.
you have an idea that about the what are the different test scores, right?
Okay, fine, sir. Thank you.
This is particularly for this examples. Even if you get the another examples, we have the very good examples here in the R itself, that is MPG, right? Right. So we, as another example, we have a data of empty cars, right? If you would like to know more about data, you can put it here and then you will get it. Yeah, right. So motor trained car roads tests, right? This data is given, and in this we have the certain cars of the other brand along with their MPG, cylindrical performance, displacement, HP, draft, weight, etc., is given, right? Now, if I have to predict the MPG, mile per gallon, right? You can see all those things here. Mile per gallon. What do you think? Which kind of other variables would be helpful? That you need to decide, right? Because you know about the data set. So that's why I said initially that it's very, very important to understand the data set first, right? Does it does it have any kind of relationship between the other variables which was given in the data set or not? If yes, then which variables are highly related, which variables are not very highly related, right? Those all things can be discussed and used to predict any kind of dependent variables here. Yeah, can you give me the responses what I asked?
Yes, sir. But this is too technical. We are not aware that what are the parameters. But yes, now I got your point that you decide logically that which parameter affects
Yeah,
the,
definitely,
the
definitely.
yeah. Yes, sir. Yes.
Definitely. So as I said, and I was very happy that quickly you said yes, the expenditures would having the effect on the test scores, right? Because when you have the expenditures on the school, it means those all facilities would be given to the students of these schools. Maybe kind of smart boards, maybe a kind of activities, maybe a kind of computer systems, the technical knowledge, etc. And those will certainly increase their knowledge, their ability to gain something, and definitely that would be affecting to their test scores. That's what the general perception is.
Yes, sir. Yes, sir. Thank you, sir.
Okay, anyways, so you can do that exercise later on, maybe if not now, and just you need to replace the str by the expenditure or any other variable which you feel may be related or may be influencing to the test score, right? And then you can perform. And I would also request you to perform this simple linear regression exercise based on this empty cars data, right? Where the different brand of cars is given along with their certain other variables, right? So you can see which can be treated as the uh, uh, dependent variables, and then further what independent variables can influence them, right? So can later on we can also decide, can mpg would be related to the weight, mile per gallon, right? Mile per gallon can be predicted using the weight of the cars, right? You may understand why I am asking this. Later on you can also make it to the multiple regression without, means you can use one variable as maybe, if I talk about the our original example str, so one variable can be str, the another variable can be expenditure, the the another variable can be anything else, whatever you see it here, right? Maybe you are discussing this multiple regressions tomorrow, so you can do that exercise later, and then you can come for the class to gain the better understandings, right? We can also see this, we can also categorize this based on the countries as well, right? So can we have the different performance country wise, etc.? So many other things can be done using the same data sets, right? And you can explore as much as you want. Fine, that's all from my side now here. If you have any specific questions, I'll be happy to discuss with you those things. I believe you have understood majority of the things here along with the practical aspects. And whenever you have the data set, you can load it into the R, prepare a data frame, and then you can perform all those exercises which we have seen today. Right? Fine. Now the forum is open for the questions. Please feel free.
Sir, when you are saying that multiple characteristics can be taken, so when you have discussed the theoretical part of it, you have shown the some points with the yellow color and then green color and then black color. This will be the thing will happen, means what we suppose
No,
in multi. Yeah.
no. Multiple was then we have written so far the y is equal to beta 0 plus beta 1 x, right?
Yes. Sir. Yes.
It might be beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on.
Oh, okay. All the things will combine and then it will
Right,
occur.
right,
Okay. Okay.
right.
Fine. Fine. Okay.
So definitely it will increase your prediction,
Yeah. Yeah. Yes.
right?
Yes.
Then
Yeah. Thank you,
later
sir.
on, yeah, thank you, please. Welcome. Yeah, anybody else, if you would like to add something?
Dear participant, any question, please?
Perhaps they are waiting unless you invite them. Right.
You can unmute your mic to put your question or further anything which you want to add.
You can even write in the chat box, no issues. We will, you know.
Sir, I just have just one thing to say. So I think multiple regression has much more advantages over linear regression. I think because when we are considering so many factors to predict a particular thing, so that will definitely have a good prediction as compared to linear regression when we have one particular characteristic to do it. So
Definitely,
that's so.
definitely, yes. But at the same time, it depends that in what situation you are dealing with. When one of the variable is particularly able to explain your dependent variable to an extent of 92%, 93%, and then you have added one more variable and it is explaining 95%, right? So
Yes.
that one variables model, which is a simple linear regression, perhaps the better than the multiple one because it is not complex,
Yeah, that's true. That's true.
right?
Linear is a much easier
But
model. It's a
yeah,
simple model.
but if there is a difference of the explanation of the dependent variable, let's say 20%, 30%, then it is always better to use the multiple regression model, right? But if it is
Yes.
around 2-3%, then obviously you want to use the model which is simpler in nature, maybe further able to deal with those models, the interpretations, those all things, rather than you can compromise with the 2%ers of the explanations, right?
Yes. Yes. Right, sir. Like the example that you took, in that example, you took STR to predict the test score. If we add one more expenditure, let's say, for example, the expenditure is influencing the test score much.
Definitely it
So
will
that
increase.
will
Yeah,
become a
certainly
multiple
you are right.
regression model. And that will
Certainly.
might give a good test score if I just add that
Yes.
expenditure or maybe some other characteristic if I
Yes.
find out.
Definitely. Definitely.
Okay. Okay, sir. Thank you. Thank you, sir. Thank you.
You are absolutely right at this point.
Sir, what about errors, sir? Means can we, if we are not getting good regression means, so can we put it in error, or means error concept, how can correlate with characteristic?
Uh,
Means,
error is the different scenario altogether. That's a randomness, right? That's a
okay.
randomness involved. It is not because of these explanatory variables. Rather, this the some randomness which comes into in between.
Unknown thing which is coming in
Some
that
unknown
data.
things
Okay.
which we have no control on it, so we don't
Okay.
consider these things into our predictions because we don't have any control on it. Unless if we have the control on it, then we will definitely you have taken care of it, and then we would have used it somewhere.
Okay, sir. Okay. Thank you, sir. Okay.
So tomorrow you will be going through this multiple regression model. I believe you have there in a session. So you will be having, the much better understandings in terms of the predictions using the one variables, which we have done today, and then maybe two variables and three variables. So what actually happens, as one of you asked, that certainly when you increase the variables, our prediction may increase, right? But then it depends how much it is being increased, right? Like I can show you the examples. If you put the regression lines in linear regression line, and then if you use the polynomial regression, right, then definitely the polynomial regression is somehow better than the linear regression, but then the model is being complicated. And if it is not a very reasonable amount of contribution in the in the prediction, then perhaps it's better to use the simple linear regression model over the any other one.
Sir, when we conduct the experiment with our students, it happens sometimes that if we are taking 4 or 5 readings or 10 readings, let's get it. Then if we remove some readings, means we don't take it consideration and draw the graph, we will get the good regression. And if we add those readings, then we get the very low regression values. So
Right, right.
why it is so, sir?
Actually, the as I shown you one example there, and if you remember, so there was a point which I called as an outlier, right? So that if I was considering that outlier, our correlation was 0.71, and if I was removing that outlier, our correlation was 0.91. And
Yes, sir.
similarly,
Yes.
that effect will comes into the regression as well. Now it's you as a researcher or as a teacher, as a practitioner, have to decide whether these values are outliers or whether these values are into my experiment, right? For
Okay, sir.
examples, if you are conducting a test, right, and majority of students have scored between 50 to 60, but one person have scored 95, so that 95 would be treated as the outlier, right? If you include this into your analysis or your understanding, then perhaps it will mislead to your answer,
Okay, sir. Okay, fine,
right?
sir. Yes.
Yeah,
Okay, thank you, sir.
yeah. Welcome.
Audience, if you have any question. Any more question, please? I think there is no more question, and a lot of discussion has been done today, and the session was really very interactive, and all the questions from the audience side has been discussed. So I hope that today's session is very interactive, knowledgeable, and informative to all the participants. So as we wrap up day 5 of our biostatistics workshop, I want to extend a heartfelt thank you to everyone for your active participation and engagement. Today's session on regression analysis has been incredibly informative. Thanks to your enthusiasm and curiosity, I hope you found the material valuable and are excited to apply these concepts in your work. Looking forward to seeing you all tomorrow as we continue our journey into advanced biostatistics. So once again, thank you to all, and thank you, dear professor, for your valuable time. And the content was really very informative, knowledgeable, and the script file which you have shared, and I hope that the participant will do some experiment by using your script file. And in the coming sessions, this will be very helpful to all the participants. Thank you to all. And tomorrow we will join the session at the same time. Thank you to all and good night. Good night, sir, and good night, everyone.
Okay, good night. Good night. Thank you. Thank you, everyone, right, for your patient hearing. And I hope that was fruitful to you, and which will take it forward and definitely work on it. For any other things, I am available. You can text me, email me for if you need any other help in this regard. Thank you. Thank you, Madan. Good night.